At the outer edge of our solar system, more than 4.5 billion kilometers from the Sun, lies a realm few have truly seen. Here, daylight is dim. The temperatures drop hundreds of degrees below zero, and the familiar inner planets are distant specks lost to the void. This is where Neptune lives, an ice giant cloaked in methane blues and circled by thin rings and faint moons. It's a planet of extremes, with winds faster than any hurricane on Earth and a core that still radiates primordial heat. But Neptune is not the strangest thing out here. Circling this frozen world is a moon so strange, so out of place, that its very existence is a cosmic puzzle. Its name is Triton, a moon that moves backward, breathes frozen gas, and hints at an ocean hidden beneath a shell of nitrogen ice. It is not a native child of Neptune. Triton is a captured wanderer, a former planet in miniature, a body from the dark past, drawn in by gravity and violence. And its origin story may be one of the most dramatic in all the solar system. Every major moon in our solar system orbits in the same direction as its parent planet spins, counterclockwise, as seen from above the North Pole. This consistency points to a shared origin, planets and moons forming together from the same rotating disk of gas and debris. But Triton defies this. Triton's orbit is retrograde. It moves in the opposite direction of Neptune's rotation. No large moon in the entire solar system shares this trait. And that anomaly isn't just quirky. It's a red flag, a smoking gun. A retrograde orbit means Triton could not have formed around Neptune. The physics simply don't allow it. It must have come from somewhere else, an interloper captured by Neptune's immense gravity. But capture isn't easy. In space, objects don't just stick to each other. Without a mechanism to shed kinetic energy, a passing object simply slingshots past. So how, then, did a body as massive as Triton, nearly as large as Earth's moon, become trapped in Neptune's orbit? To solve this mystery, scientists turned to simulations. They modeled early solar system dynamics, chaotic, violent, full of gravitational entanglements. And a compelling theory emerged. Triton may have once been part of a binary object, two icy bodies orbiting each other, much like Pluto and its companion, Charon. Together, they journeyed through the Kuiper Belt, drifting slowly past the far reaches of the Sun. But one day, this binary pair wandered too close to Neptune. The planet's gravity pulled them apart violently. One member of the pair was ejected into space, slingshot into interstellar darkness, never to return. The other, Triton, was captured. This three-body interaction allowed Neptune to steal Triton, effectively paying the cost by flinging the companion away. In a fraction of time, Triton's fate changed forever, but its troubles were just beginning. The captured orbit was unstable, elliptical, and wildly tilted. And that meant one thing: intense tidal stress. As Triton settled into orbit, its path brought it close and then far from Neptune, again and again. This shifting distance created gravitational tides, forces that stretched and compressed the moon's interior. The friction from this constant kneading generated immense heat. Ice melted, layers shifted, the crust cracked and buckled. Eventually, over millions of years, the orbit began to circularize, stabilizing into the path Triton follows today. But the tidal heating didn't stop. It transformed Triton from a frozen shell into a dynamic world, a place with geological activity, possible volcanism, and, perhaps, an ocean beneath its crust. When Voyager 2 passed Triton in 1989, it saw hints of this transformation. Plumes erupted from the surface, dark geysers venting nitrogen gas and particles, stretching kilometers into space. It was a cryovolcanic world, cold volcanoes, driven not by fire, but by frozen gases under pressure. Triton was alive. Still is, perhaps. And for a moon this far from the sun, that changes everything. We once believed that life needed warmth from a star, energy from sunlight. But then we discovered life on Earth deep in the ocean, clinging to volcanic vents where no light ever reaches, thriving instead on chemical energy. Could the same be true on Triton? Tidal heating could keep a subsurface ocean from freezing solid. If radioactive elements exist in Triton's rocky core, as they do on Earth, that heat would add to the internal warmth. Such an ocean would lie beneath a thick shell of ice, perhaps 100 kilometers deep. But it could be stable, long-lasting, and filled with possibilities. Could it host microbial life, huddled around warm fissures? Could chemical reactions, like those on early Earth, be occurring there now? We don't know. But Triton is now considered one of the most promising ocean worlds in the solar system, despite its backward orbit and distant location. And that possibility has ignited interest in a long overdue return. Triton's arrival was more than disruptive. It was devastating. Neptune likely had a full family of moons before Triton, smaller bodies in regular orbits, similar to those still seen around Uranus. But the gravitational chaos caused by Triton's capture would have torn that system apart. Some moons may have collided with one another, breaking into fragments. Others might have spiraled into Neptune and disintegrated. A few may have been ejected into space entirely. What remains today is a scarred system, a few irregular moons in strange orbits, and Neptune's faint rings, possibly the remnants of shattered satellites. Triton didn't just join Neptune's system. It replaced it. It is a moon that not only wasn't meant to be there, but also erased what once was. In 1989, Voyager 2 flew past Triton at over 20 kilometers per second. It captured just 40% of the moon's surface in usable images. But what it revealed was enough to stir the imagination of a generation. Smooth plains, cracked crusts, ice volcanoes, nitrogen frost. And yet, for all this intrigue, we've never returned. For more than 3 decades, Triton has remained in the background, a fascinating enigma, but not a priority. That may be changing. NASA has proposed a mission named Triton, a fast flyby that could map the full surface, analyze the geysers, and search for evidence of a subsurface ocean. Triton would fly by in the 2030s if approved, but funding is scarce. Competition is fierce, and Triton still waits. Triton is more than a moon. It's a window into the early solar system, a relic of the Kuiper Belt brought in from the cold. It may be the only large Kuiper Belt object we can study up close until we send another mission beyond Pluto. And because of that, it is invaluable. Its backward orbit tells a story of gravitational drama. Its smooth surface reveals the aftermath of planetary chaos. Its geysers whisper of heat and movement. And its icy crust may be the gateway to an alien ocean, a possible cradle for life beyond Earth. In a solar system full of mysteries, Triton stands apart. Quiet, patient, waiting for us to look again. A moon that wasn't born a moon. An object stolen from the outer dark. A destroyer of systems, and perhaps a harbor of life. Triton is the paradox we can't ignore. It teaches us that the solar system is not static. It is sculpted by capture, chaos, and loss. That even in the farthest reaches, nature experiments with warmth and geology. And that among the wreckage of cosmic violence, new beginnings may take root. It is more than a curiosity. It is a destination, A message frozen in nitrogen ice, written billions of years ago. All we have to do is go read it.